Hey, welcome to the series of everything you need to know about Python in simplest possible way. In this video, we will try to understand identity operators. Before understanding identity operators, there is something that we need to know how this memory allocation happens in Python. So let's go ahead and see how this memory allocation happens in Python and how Python uses optimization techniques in the memory allocation. I'm going to whiteboard and explain through this whiteboard it clearly. Let's say I'm storing the value 10 in multiple variables. Let's say I'm storing the value of 10 in 100 variables. So what happens in programming is that whenever you create a variable, a memory location is allocated to that variable. So what Python does is that, let's say I'm creating the variable 10 in multiple variables. So Python don't create all of those variables. Rather, Python having this variable, it just point to the value where the value is actually stored. So I have this where I have this like this. I may have any number of variables, but what Python does is that it will just point to all of these variables where the value is actually located. This is the memory location. Let's say I'm having some memory location. It will just point to the memory location where the value is actually stored. By using these techniques, Python optimizes most of its memory. So this is what the basic understanding of memory allocation in Python. There are a lot of things that we need to understand in this process. Let us go ahead and see one after the other through programming. So in through identity operators, let's say I might be having many number of variables, like say I have a b c, like that I might be creating so many number of variables. So I wanted to know the memory allocated to the variable a is as memory allocated to the variable b. To know that, we have identity operators. I will explain identity operators one after the other. We have basically two identity operators, which is and another one is not. Let us understand one after the other. Let's say I am allocating variable number 1 is equal to 10, and I am allocating number 2 is equal to 10. So what I am doing here is that I am allocating the same variable, same value 10 to the different variables number 1 and number 2. I wanted to know this number 1 is allocated with the same memory address as with the number 2. So to do that, I am using identity operator is to num2. So what I'm getting is true, because how I'm getting is that, let us go and see the memory addresses of these two variables. To know the memory addresses, we have a method called id. When we pass this variable to this method, I am getting this memory address where number 1 is stored. I will check the value of the address of number 2 also. When I check number 2, if you carefully observe, both addresses for number 1 and number 2 is same, because it was not actually creating a new memory, rather it was actually pointing to the value where the value 10 is stored. Let us see the value of 10. If I see the value, the address of 10 is same as the address of number 1 and number 2, because it was not create, because number 1 and number 2 are not created, rather these number 1 and number 2 are pointed to the value where this 10 is actually stored. So this is how I am getting whenever I execute number 1 is number 2. So when I execute this, I am getting true, because of that reason both are pointing to the same address location. So by this, you can understand that is operator returns true when both variables pointing to the same memory address. So I will create a new variable number 3. I will assign 20 to this. Now I will check number 2 is number 3. I will get false, because these two variables pointing to the different memory location. Because of that reason, I am getting false. If I check number 3 address, I am getting something different address rather than number 2 address. You can see here. So like this is operator works. If both variables pointing to the same memory location, it will get return true. If not, it will return false. This is about is operator. What exactly this is not operator works is that we have seen number 2 and number 3, right? So if I put is not instead of is, I am getting true, because how it works is that if the both variables point to the different memory locations, at that time the is not returns true. if both variables point to the same memory location at that time, is not returns false. So we are using is not, and we are checking with the different variables, so pointing to the different values. Because of that reason, I am getting true. If I check number one is not number two, when I check this, I am getting false because these both are pointing the same address locations. Because of that reason, I am getting false. I hope you have able to understand this num. You can able to understand this is operator and is not operators. There are so many things that we need to understand in this case. Let's say I am creating a new variable which is of maybe n1, which is of 244. I am creating one more variable which is of n2, which is of same 244. If I check n1 is n2, I am getting true. There are some things that we need to know. This is fine. This is completely fine. I will check with some other number. Let's say I am creating n1 is equal to 300, and I am creating one more variable n2 is equal to 300. You can see the same variable, same value I am assigning to two different variables. If I check n1 is n2, I am getting false because see, observe carefully here. I am assigning same value to the different variables n1 and n2. I am just comparing this n1 is n2 because whenever I compare this, I am getting false because Python uses something called integer caching. How this integer caching works is that it will the Python follows some numbers they stored in the memory. Those numbers are -5 to 256. These are the numbers that Python stores in the memory. Apart from these two values, if you try to check any other value with is operator, you will return that will return false. You can see this 300 is above 256. Because of that reason, though values are same, I am getting false. Like that it works. If I check minus 6, not minus 6, I will directly n1 number 1 is equal to -6 and number 2 is equal to -6. If I compare these two values, number 1 is number 2, I am getting false because the number 1 and number 2, though the values are same, it was not in the range of -1 to 256. Because of that reason, I am I am getting the result as false. I hope you can able to understand because the how this memory allocation is works in a way that -5 to 256 are the values stored in Python in some memory locations. Whenever you create any variable in this range of -5 to 256, you don't create a new value, don't allocate the memory. It will just point to the memory where these values are stored. If you create any value other than these to this range of values, a new memory will be allocated. Let me check this number 1 and number 2 IDs. If I pass ID to number 1 and ID to number 2, I have the values of -6 and -6, but the memory you can observe here is completely different. Here, at last, I am getting 8688. Here, I am getting 9328. So, the memories are allocated to these two variables are completely different. So, that is about integer caching. Let us go ahead and see with the strings how this works with the strings. Let's say I am having S1, which might be maybe like, and I am having S2 which is also like. I am demonstrating for is operator. Because of that reason, I am taking the same strings. S1 is S2, so it was working. So because of the reason, I am giving the same values. So this is how the strings also works. Strings works in such a way that string uses a string interning. How the string interning works is that whenever I am giving capital A to capital Z, capital Z and capital A to capital Z and small a to small z, and also 0 to 9, all these values, whenever I am passing string in these values, it will return false, return true. Apart from these values, if I give any other value, it will return false. I will take the same example and change a little bit. At last, if I pass at the rate, You can see here both strings are having like at the rate. If I check S1 is S2, I am getting false. Because of that reason, at the rate is not part of these values. So A to Z minus A to small a to Z or 0 to 9. Because of that reason, though these two strings are same, I am getting the result as false. I hope you can able to understand these strings. Let us go and see some more things with these identity operators. We have different collections like list, tuple, set, dictionary. For all these collections, though the elements are same, the result will be different. The memory allocated will be completely different. So let us go and understand one after the other. Let's say I have this list. I am having 1 and 2. Because to make it simple, I just copy this. I am pasting here and I just change the variable name L1 to L2. If I check L1 is L2, you can able to see the values of L1 and L2. Both are having the same values, list of 1 and 2. If I execute this L1 is L2, I am getting false. The reason it is the memory is allocated for L1 is completely different for the memory allocated for L2. If I check ID of L1, I'm getting this. If I check ID of L2, I'm getting this. So you can able to see I'm getting completely different memory for L1 and for L2. So like this, all for any other sequences works. Let's say I'm having this list tuple L1 and L2, tuple T1, and I also consider a tuple of T1, T2. If I execute this T1 is T2, I'm getting the results as false because though the values are same but the memory is allocated is different. I will consider maybe of set S1 is equal to set of 1 comma 2, and I will take the same set and I will change the name as S1 as S2. I will compare S1 is S2. I am getting false because the memory is allocated completely different. Let us try with last example, which is of dictionary. D1 is equal to 1, which is of 10, and 2, which is of 20. I will take the same dictionary, but the values will be complete. The memory allocation is completely different. If I check D1 is D2, I am getting the result as false because D1 allocated with completely different memory with D2. So because of that reason, I am getting false. So you might be asked that we have these many number of problems with identity operators, then why should we use and where should we use? So the answer for that is we mostly use these identity operators with true, false, and none. So these are the most frequently used by the any programmer. So it knows to the Python developer. So because of that reason, these are having some fixed memory locations. Whenever these values are calculated, the values should be directly pointing to that memory address. So let me demonstrate with this some kind of a example. Let's say I have number one which is of 10 and number two which is of 20. If I compare, if I do some kind of an operations with both of these value, if number one is greater than number two, so number one greater than number two is false, is I will tell this as false. It will return false because I need to put this parenthesis here because of the priority is more for this. So because of that reason, I'm getting false. So now you can see the result as true. So this memory address located for false and this memory located for this expression is exactly same. So let me check this ID for this operation. If I check ID of this operation, I am getting this ID, remember, and if I check the ID of false, I am getting the same ID, same address as I am getting for this expression. So you can able to understand whenever I am executing this expression, this return some value which is of false and false is having the address of this. So because of that reason, this is operator works exactly and excellently with this kind of situations. Let me demonstrate you with some other example. Let's say I am putting greater than here, and I am putting false here. I am putting true here. So number 1 is less than number 2. 10 is less than 20. This will return true, and true is true. I will get true. Because of that reason, it is not comparing the values, it will comparing the addresses. So like that, we can use this true, false, and none. If I put a equal to none, and if I check a is none, I will get the result as true, because the memory is allocated for A and the memory is allocated for B is both same. Because of that reason, I am getting this true value. So to summarize and explain you clearly, I will go to the top and explain you. So previously we have understood about memory allocation and memory optimizations by Python. So later we have discussed is operator and is not operator. Python uses something called integer caching. It will ranges from -5 to 256. Any values from in this range, the is operator works excellently. Any other values other than this, that will not works for is operators. A new memory allocation will be happen for those variables. Because of that reason, we will get false values though the values are same. We have understood the string interning. String value stores in these ranges of z capital A to Z and small a to z and 0 to 9. Apart from any other value of these values, we will get the is operator false. We have seen also that we have seen collections, list, tuple, and set. Though values are same in those collections, the result and the memory allocation will be completely different. So we have seen where we could actually potentially use this in true, false, none. In these cases, we can actually use this effectively. So the main idea of is identity operator is to compare the memory locations, not the values. So that is the main thing that you need to keep in your mind. When you are comparing the values, we have the comparison operator equal to. By using this equal to, you can actually compare the values. But if your intention is to compare the memory locations, at that time only you need to use this is operator. So if you are interested in comparing of values, you need to go to this equal to operators than is operator. So that's it for this video. I hope you have found this video insightful and interesting. If that is true, hit the like button and comment your opinions, whatever you have opinions on this video. And I will see you in the next video. Thank you.